Hey everybody, Robert Gloria here. Today I want to just talk about some of the connections I've been making recently. This has happened like in the past couple weeks in my classes, and I've been teaching illustrative math, also known as open up resources, for 5 years now, and I am fully on board. This is the year where I think everything is just really clicking. I taught sixth, seventh, and eighth. um, Taught sixth grade for the first time last time, and so I was able to really appreciate the full sequence from sixth to eighth, and really see how it the foundation is set in sixth grade, and how it just kind of unfolds through seventh and eighth. So just a beautiful math story, and this curriculum is just really high level, and my kids are achieving and having fun with math. It's just overall just amazing, and I think getting to the point where you can implement it with fidelity and successfully is obviously a goal for all teachers implementing this curriculum. And so I just want to let you all know, just inspire you. There's light at the end of the tunnel. There is a reason for everything that's done, and it takes a very long time to really understand it fully, to really appreciate it. And I recently did a lesson in seventh and a lesson in eighth. I'm going to go over both of them to really just show you just the beauty of it. And let me go ahead and share my screen. And I'm hoping that this video will just kind of help people who may be on the fence, about the program. I know, I've met a lot of people who are like, oh, I'm not sure if this is working. I'm not sure if my kids are learning at the rate I want them to. There's a lot of people who doubt it. Okay, but I just want to show you these two, just to kind of give you an idea of where the whole thing is going, because I think that these two activities really really highlight that very very well. And you'll see it throughout the program. There'll be like some aha moments where it's like, oh man, this is just beautiful. The thing that comes to mind, my all-time favorite, is the linear equation, how linear equations is introduced to eighth grade. And that's just it's just this idea of you're kind of forming their conceptual understanding, right? We're kind of exploring, and then once you develop that, then you can start to develop procedural fluency. And I think that's the thing that a lot of teachers have a hard time with. Sometimes it's just, being patient and understanding that, the work we're doing, the kids may not master it every day. If they don't master the cool downs every day, it's okay. We can, we're gonna have so many opportunities, and it's just, there's so many benefits of using open up or illustrative math. And so is this is lesson 3. I'm going to show you. This is unit 4 of seventh grade, and it's called Revisiting Proportional Relationships. Now, if you're familiar with seventh grade sequence, well, we start with scale drawings, and then we go into units, or scales. Okay, and then the second unit is kind of applying that same concept, but we're looking at just introducing the idea of a proportional relationship. Now, the way that it does this, having taught sixth grade, I know very well that it's this concept is introduced as equivalent ratios and also unit rates in sixth grade. I mean, those are the main ideas that they're hitting, and you can see that here, right? Equivalent ratios. And one thing that happens in seventh grade is that they're kind of reframing they're reframing their minds as to what it is that the unit rate and the equivalent ratios mean, right? And so we're reframing it as proportional relationship, and then eventually constant of proportionality. And this is really useful as they go through it, because if those of you who know eighth grade, but if they go into eighth grade, they have to know constant proportionality, and then they're going to tie that into slope. And so, and they learn how to graph, of course, and so that's kind of where that's at. Now, going to Unit 3, it's amazing. Unit 3, because, and this is like one of the most amazing things I experienced when I started teaching this, is like, okay, we did constant and proportionality, and then they apply constant and proportionality, proportional relationships, to the study of circles, and this idea that the circumference and the diameter, it's a proportional relationship. And so by Unit 3, the kids have a very strong understanding of a proportional relationship, right? And if you stick with it, and if you teach with fidelity, they're gonna master it. Maybe they may not master it in Unit 2, but Unit 3, another opportunity to master it. And then Unit 4, check this out. Unit 4, hey, they circle back to it. Look at that. And then guess what? They're gonna circle back to it in eighth grade when they learn about linear equations. It's gonna be, okay, let's remember what proportional relationships is, right? And so open up, and they really do an amazing job of just circling back. Hey, this is what we learned, you know, just that understanding that, like, kids are not always going to remember everything, right? And that's not a realistic expectation for us to have for our students, right? That it's not going to happen. uh they're going to forget concepts over the summer, over the course of years, and we have to spiral. And just going through those 3 units, so you can see how everything is spiraled, throughout. And another benefit, of course, of the curriculum. So in this one here, okay, so you've got this idea of, well, you got to get some rope, and then if you're not familiar with sixth grade work, well, this right here, this is called they call it scaling, or scale factor, in sixth grade. Where they're encouraged to multiply vertically, right? So what times 6 is 1, and then you multiply that same multiplier right here on both sides. Okay, so this is a sixth grade strategy. And you'll find that your students, especially those who have mastered this strategy, they're going to look at this and say, oh, I can very easily multiply this by 50, and then find the answer easily here, right? And so they're kind of encouraging them to utilize that strategy here. And mind you, this is kind of after they have already learned about the constant of proportionality, right? And so it's just one of those things. Now, the cool thing about this is this girl Priya is saying that she can solve the problem with only 2 rows. And so not only are they hitting that sixth grade skill, but then they're also saying, okay, well, here, I mean, you could also do the same, right? You can go 6 times a number equals 50, and then do the same here. But the idea is that students are seeing, well, you know, 6, well, I don't know what number times 6 equals 50, right? So that method doesn't always work, right? And that's kind of the idea. We're building the conceptual understanding for these students, and then of course it's resulting in procedural fluency. If they're able to do this, right, they have reached procedural fluency. And if they can explain why it works, then they've also mastered the conceptual side. And that's the goal with every concept, right? We're not drilling, we're not killing and drilling. It's just, why are we doing this? Making sense of it. We're always explaining our reasoning, right? Uh, and in this case, they should be able to say, well, 6 times 1.25 is 7.50. And so that's likely how Priya got it, because she only got 2 rows, right? And without that unit rate, it's going to be more difficult. In fact, let's see what that number is. 50 divided by 6 And you open up and they do a really good job of like giving students tools, right? They give them tape diagrams, double number lines, in this case tables, and then equations. And the goal is that they understand how to use them. And a lot of teachers I've spoken to over the years, it would be like, oh man, why are there so many strategies? It's going to confuse the kids. Let's teach them one method. And a lot of teachers use cross multiplication, for example, right? Now, you should know that cross multiplication is not even used in the curriculum, and the reason for that is if you can cross multiply, right? This is purely procedural, and there's no way to understand it conceptually. You're cross multiplying and you're finding the answer successfully, but you cannot. There's no way to explain why it works. Is the problem. And so that's why that's a strategy that's not used. A lot of teachers will be like, "Oh man, why are we using all these strategies?" Right? Well, this is it right here. This strategy, the scale factor strategy of multiplying vertically, does not work here. The number is actually a very long decimal. It's a repeating decimal. Now, the problem with that is, unless you keep all the threes, you're not going to get the exact answer here. This answer is not going to be exact anymore. And so that's something that the students here should be able to understand. They say, oh, you know what? And a lot of my students in class, they'll be like, oh, Mr. Gloria, this is what I got, and they'll show me and they say, oh, well, what am I supposed to do with that? Should I round or, and some kids do try rounding and, then the answer is not the exact answer. So they've approximated an answer, right? But that's not always good enough, right? And so in this situation, it's kind of the curriculum is forcing them, right? It's forcing them to think about it a different way. Like saying, this is one way to do it, sixth grade. This is the seventh grade to do it now. Okay, you got to multiply 50 times 1.25, and it'll be 62.5. Now it gets even better than that because, and this one just blew my mind. When I saw this, I saw it in real time. In my classes, and sometimes you don't we plan these things. We try. One of the things that you need to be doing is like exactly what I'm doing here. Is just making sure that you're doing the work. You're doing the work with students, or actually, doing the work on your own before you teach it. And that's something that uh, sometimes teachers don't have time for. Understandable, obviously. No judgment there. Happens to all of us. But if you're not fully planned and you cannot see all the angles, all the possible strategies, especially if you only teach seventh grade, maybe you never taught sixth grade, you may not even know about that scale factor method, right? So you may have to really put some extra thought into it. And so it's not always going to be clear to us. But this one right here really blew me away because it's like first of all, they gotta put these numbers in the correct location. So that's a skill, right? Reading, annotating, and then putting that into the table, right? So that's a skill. Obviously, we have to support them if they're kind of struggling there. That's the other thing. A lot of teachers who first implement this program think, oh well, hey, let's roll this out and see what happens. And they're surprised when they look around and the kids aren't doing anything. They're like, ah, man, this program doesn't work. The kids aren't working, right? But that's not the case. A lot of times we have to remind them, hey, let's annotate. All right, what do these numbers mean? Where are we going to put these numbers, right? Where do they go? And for this one, you might use the three reads strategy, right? Where we're kind of reading it together and then, supporting them any way that you can. But this is where they should put all of the numbers. Now, one thing that they will find here is that, okay, you could use this scale factor method. Okay, this actually could work. And some students will do that, certainly. It's a clean enough number to be able to work with, right? 75. It's not a repeating decimal. And boom, we can get the answer like that because 75 times 3 is 225, right? Now, most students in my classes did that, right? And they said, all right, that's the answer. Now, the other thing about IM and Open Up is that we want to make sure that the variety of strategies are on the table and that they're getting exposure to that. Because think about this, for example, what happens if some of your students never mastered this scale factor method, right? They never mastered it. And that's the case. In any given class, that's going to be the case, right? Maybe students feel way more comfortable with the 7th grade strategy, right? And that's part of it. We know in math, like if students don't master fractions, then they tend to lean on decimals, right? And that's just the natural course of mathematics. It's just, okay, I don't know this, but is there another way to do it, right? And if they can do that, then we're in a good spot. Now, this one here, okay, maybe your students don't remember this or never mastered this, right? Or don't see how you can multiply here. And so they say, you know what? I'm going to do 8 divided by 3. Because at this point, Unit 4, it should be sufficiently mastered and, procedural, the procedural fluency of this. Some students think of it, divide right to left, or there's a lot of ways that they can think about it. But the problem comes up again where 8 divided by 3 is a really ugly decimal. It's a repeating decimal. And some of my students certainly write it all down, 2.6, and I see it on their paper, and it's like, all right, they're going to work with it, they got to plug in all of these digits into their calculator. Otherwise, they're not going to get the exact answer, right? Because it's going to be, if they estimate or round, for example, it's not going to be an exact answer. So if we're asking them for an exact answer, well, this is most likely not going to produce it. And so again, the students have to think outside of the box once again. And in this case, I had some students really they blew me away because they didn't know this strategy, they didn't remember it or master it, right? And they found this number to be unwieldy. They didn't want to bother with it, and so they quickly moved to a different strategy. And it's this one right here. In the student response. Okay, instead of dividing 8 divided by 3, right? They divided 3 divided by 8, and this is the constant of proportionality. If we're multiplying 8 times 8, right? And this is something that the students learn at the end of Unit 2, where they're the proportional relationship unit, where there's 2 constants of proportionality for every relationship. And so if they master that, then this is where it's going to show up, because of all the methods, this one is not the best anymore, but this one is. Okay, so 0.375 times 8. Well, hey, we're going to do the same thing. We're going to multiply it by 600 to then get 225. And this is one of those lessons where your students' mastery and the procedural fluency is really going to come into play here. If they're fluent if they understand the concept, but not only procedurally fluent, right? Because these are three different ways of finding this answer, right? And again, there's a variety of strategies introduced because we don't want them to abandon this just because they're in seventh grade. I encourage my students who like this strategy to continue, and that's what we should do. You go with whatever tool is the best, whatever strategy is the best, but knowing that this strategy is not always going to work at the same time, right? And this strategy is not always going to work, and so we always have to have tools in our math tool belt, in our math toolkit, in order to figure out what's the best way to do this. So yes, it is procedural fluency, but it's also the conceptual understanding as well, right? Because if you can understand, there's there's multiple ways of seeing equivalent relationship between 3 and 8, then you will be able to understand like this is my best bet. This is the constant proportionality that I'm going to use here. Okay. And so that's just again one of those lessons where I don't know, for me it's just like everything just came together in that moment. And honestly, I planned for this lesson and honestly I did not anticipate that anybody would do this. Um, you know, but when it happens, it's like, oh, the kids just blow you away, right? And so this is why we want to make sure the students are maintaining that cognitive load, right? Like we're not supposed to tell them, hey, check it out, you can do 3 divided by 8. You want them to kind of work with it, problem solve. You want them to talk to each other, compare their answers, ask questions, right? You want to ask questions of them, and you want it to come out organically. Okay. And if it doesn't, some of my classes didn't get this, right? If it doesn't come out organically, well, you can mention it, you can teach it. Um, but in a lot of those cases, well, they use this, so that's perfectly fine, right? So it's just a matter of what you want to elaborate, but just keeping that door open. Um, and making sure that they understand not only getting the answer right, but what does the answer mean? Obviously, in this context, but how did you get it? Like, why does your method work? If they can explain that, then you could pat yourself on the back because that's the goal, right? And that's why we're constantly asking them to explain the reasoning. We're constantly asking them to prove, their claims, give evidence. This is one of those lessons where it really, really shows up. So I wanted to highlight that one. Now, there's one more. There's an eighth grade. Now, this one was really interesting because I have a teaching partner, and we were we were talking about this lesson. Okay, let me situate this for you so you know where we're at. Okay, so this is lesson 10. We're in unit 2. Let me go back to the units. And so in the units, you start with these rigid transformations, and then they learn to apply that to dilations and similarity, and they start to apply that to slope through similar triangles, the slope triangles. And at first, when I first taught this, I thought it was very wonky, and a lot of teachers experience the same thing. So if you're feeling that, that's real. That we all go through that because most of us didn't learn this way. We never really learned the conceptual side. Like for a lot of teachers, they say, hey, let's just let's just give them the old slope formula. Why not? Hey, it worked for us, right? We learned it, we memorized it. Or also, I hear a lot of rise over run. Let's just teach them rise over run and have them practice. Let's do it. Now, by doing that, just like that example I gave with cross multiplication, where what we're doing is we're running the risk of of achieving procedural fluency, which is what this does, without the conceptual understanding. Rise over run, learning this algorithm, slope formula, there's no guarantee that they're gonna understand the conceptual underpinning of it. They're not gonna understand what that even means, right? And so it's our obligation to, again, implement the curriculum with fidelity so that, and make sure we understand, right? Because this was hard for me to understand. It's hard for a lot of 8th grade teachers to understand this. Like, why are we doing dilation? Why is that in the same unit as similarity? Why is it connected to slope? And these are all valid questions. And we have to really work hard to go through the lessons, understand them, read the lesson notes, right? Apply the supports that our students need, differentiate so that we can get there. Now, let me go back to this lesson here. So it's meet slope. This is the first lesson in which slope is introduced. Of course, to the context of similar triangles. So at this point, students understand that these triangles are similar. This is actually activity 1. Similar triangles of the same length. And what they're supposed to do is explain why the 2 triangles are similar, okay? And what I did, I was collaborating with my colleague who also teaches the 8th grade curriculum here, and he had asked me a question about um, a slope problem that he was having some questions about, and we had talked about that and kind of worked through it so that he understood. It was actually very similar. In fact, let me show you that first, because I think this is a good kind of example of what I was doing for 7th grade for the 8th grade. Okay, so this is one of those questions. I believe it was cool down. And he had come to me and he said, you know what? I don't really understand how the students are supposed to get this, right? And so we kind of worked through it. And so this is what the conversation was like. So he said, well, look, this is 3, right? And so this is 4. Okay. And so they're supposed to find the scale factor here from the first to the second. And he was like, the same thing that I was talking about with the 7th grade. He said, well, you know what, Mr. Gloria, this is a really ugly number. It's a big repeating decimal, right? This is going to go on and on and on. So he said, they're not, this is not a friendly number. They're not going to know, what to do with that number, right? And so we're thinking about it, and we were just kind of problem solving, like, is there another way that we can solve this? Because this is not the most efficient way anymore. And IM/open up, they do this on purpose, right? Like, they do this so that students can have the same questions. Like, it's a problem-based curriculum, and so as a result, it's problem-based. It's we're supposed to run into problems, right, like this, and we're supposed to say, wait a minute, this strategy of finding the scale factor, it doesn't work anymore. So what do we do? And so we kind of worked through it. We talked about it, and I don't know if it's actually here. Yeah. So you see in the teacher notes, it's saying that the scale factor is 1 1/3, right? And that's what we kind of decided as we were thinking about it and working through it together. And it did take some time, for us to really grasp what was happening. And so it's just amazing to think of, 2 math professionals kind of stumped, or, on on a question, and just trying to figure out like, wait, how do we do this? So if they know their fractions, they know that this decimal right here is 1/3. So what we decided is if you keep it as a fraction, right, it's actually easier to understand. Now, I had mentioned earlier that a lot of students kind of avoid fractions, right? And they defer to decimals. So this is one of those things. That's what I love about the curriculum as well, is like students cannot run away from fractions. Like they don't allow it, right? Because decimals are not always going to work, and so you have to really master these fractions. Okay, so we can say that well, this is so some students will be able to say, oh, this decimal is 1/3. So let me just utilize that, right? And that's because 3 times 1, of course, equals 3, right? And then 3 times 1/3 equals 1. So it's 1 plus 3, and that's going to give us the 4. And so as you can see, keeping it as a fraction, is going to be much, much better. So if they can see that either through the decimal or just through their math reasoning, that's where we want them to be. And then they can go like this. Okay, what's the length here? Okay, well, it's 4 times 1/3 again, right? And so do the math. It's going to be 4, and then this one is 4/3. So 4 and 4/3. Okay. Now 4/3, of course. What we can do is look here and say, well, does this look like 5? Well, yeah, it's greater than 5. Yeah, it's 5, 5 and 1/3 there, right? And so this makes sense. We don't need to know what this exact number is. And, they designed this on purpose, right? Because if you're trying to find a scale factor from here, that's not going to be possible, right? Because you would have to estimate this. So better to work with the fraction and then double check this side. Oh yeah, that looks about right. Yeah, that does look right. And boom, we're done, right? That's 5 and 1/3. And then students can then write their scale factor. Okay, so again, I'm showing you this just to show like the process. This is what hopefully you all have somebody to work with and talk to and collaborate with, because this program is not easy. We did not learn like this, most of us, and so it's uh it's going to take some work. It's going to take a lot of work, and we're going to get stumped at times, and we're going to be like, what, how does this make sense, right? Like we're not going to understand, just like the students, right? So we have to work through that. We have to work through that before we deliver this lesson to students, because you don't want to be in, in the middle of class realizing like, oh, wait a minute, that that's not going to work. And then what, right? Like, what are you going to do then? And so that's the importance of planning. Let me go back here. And so this one, it was they introduced slope and just understanding that, we're going to divide, and that once you divide the vertical length by the horizontal of each triangle, well, you're gonna get the slope, right? And we can look at the teacher notes and see the reasoning for this. Now the thing is, what after this lesson, okay, I wanted to make sure I wanted to make sure the students were thinking about this in a lot of different ways. And so I went up to my colleague again, and I just had this question. I said, you know what? According to this, right, just off of this activity alone, if we draw a slope triangle, like anywhere, right, anywhere here, let's say we draw it here, I showed him, I did the math, showed him the paper, right? So, well, look, this slope triangle is going to have the same slope as all of the other ones, right? And so I asked him, I said, why is that? Oh, why is it that you can draw a slope triangle anywhere off of this line and it's going to be a similar triangle every single time? And it's going to give you the slope that you need. In this case, this triangle gives it to us pretty clearly, right? This is 3/4, 3/4, same as here. And this one is a fraction, a little bit more difficult to see, but I believe it's a half, so that one's not as difficult. And then, looking at all of them, obviously the slope is going to be the same. And we really had a hard time thinking about that. We really were like, well, wait a minute, why does this work, right? So I told him, you know what? I'm going to propose this to my students. I'm going to ask them, and this is the next lesson in the beginning. And man, would you believe? We actually eventually came up with the answer. But when I asked the students, my God, it was just amazing. I wish I could have recorded that conversation because the level of understanding that they had as a result of all of this work with transformations, dilations, and with similarity, they had established a very strong conceptual foundation. And some students said, "Oh, Mr. Gloria, well, look, you have you know, you have these lines right here. The line for every triangle that you draw is going to be parallel, Mr. Gloria, right?" And so we learned that the transversal, well, since since these two lines are parallel, right? Well, hey, these angles are going to be the same right here. These two angles, right? I said, wow, mind blown. And and then they said, well, Mr. Gloria, look, you know, we know this is a right angle. These are right triangles, right? And so, Mr. Gloria, if these two angles are the same, then this one has to be the same also, because we know that if two triangles are the same in a if two angles are the same in a triangle, well, the third one is also going to be congruent. And then some of them pointed out, well, look, there's another transversal there, right? There's another set of parallel lines. So yeah, that must be true. And so they're coming up with all these proofs, and they were just explaining, explaining everything just so fluidly. And it just blew my mind, because here we are, two adults teaching the curriculum, right? And trying to grasp our heads around this, like, what, why is that, right? And then you have the students, because they've gone through the curriculum, they're able to answer. Some students answered it a little differently from others, but they were all able to understand why, right? And so this is another beautiful part of the lesson where it's not just about finding the answer, right? It's just like you wanna have these check for understanding with the students. Like, okay, you know what the slope is. You can understand that. You can find it. That's the procedural fluency of dividing vertical by horizontal. Now, what does that mean? What does that mean in this case? And and why do these slope triangles work all the time? And so it's a really beautiful thing, that we're really um explaining. And the other thing is, this is y, and this is x here. And so the other thing that came up in the conversation is that, well, 3 divided by 4 is you're taking y, right? You're taking y and you're dividing it by x to get the slope of the line. Well, the slope of the line is not some abstract concept anymore, because my students were able to explain what it meant. in terms of what they learn in 6th grade and 7th grade. So it's all tied so tightly together. And if you can see that story, right? If you can see how everything they do leads them to this point in time, and some students understand that, it's how much y, for every x, how much y for every x. Or some students are saying, well, it's the unit rate. Other students are saying, well, it's the constant proportionality, right? And or just so many different ways of thinking about it. And so if they can do that, right, like we've done our jobs, over the course of several years, 3 years in this case. And that's kind of the goal. That's kind of the goal of all of this, because the slope is always going to be a fraction, right? It's always going to be a fraction, and they're in 8th grade, so they they understand, okay, it's rise over run, and there's no problem teaching that, right? But at the same time, we want them to understand that not only is it a fraction, which is the slope, right? It tells us the steepness of the slope, but it's also telling us that y is 0.75 when x is 1. Okay, that's what it's telling us, because we're dividing y into x. How many of y for every x is what we're asking. In this case, it's 0.75. There's 3 parts, right? 3 parts of y for every x. So y is actually smaller than x, right? And if you have a slope like 2, then that means that the y is 2 times bigger. So not only is it a steeper slope, obviously, but if you can get them to this point where it's not just slope, it's not just a fraction that's telling us the steepness of line, but other really profound information, the unit rate, 0.75 of y for every 1x, or the constant proportionality, right? It's a proportional relationship in this case. Well, that means that we've done our jobs and the students have mastered what they're supposed to master. And if they don't bring it up on their own, we can always remind them, right? We can always remind them, oh, what did it mean when we divided the y value by the x value, in the previous lessons. And then we can have a conversation about it, and we can understand what's happening in this situation. But I hope that you understand. I hope that you see the beauty of the curriculum and how everything just kind of unfolds, and it's all kind of tied together. Obviously, like I said, I have the advantage of teaching 6th, 7th, and 8th. And again, if you're teaching this for the first time or second time, it does take some time to really process everything and understand it in this way and make those connections. And so I hope that you give yourself grace, and I hope that your administrators also, are patient when it comes to this. But I'm here. If you need any help, please let me know. And I really appreciate you watching my video today. Have a great night, everybody, and I'll see you next time.